check if two planes are parallel. They are. Second, pick a random point on one of the planes, plane 1. Actually here 0, 0, 0 is a pretty nice point. Third, find the reflection of this point on the other plane. How? Use the method that we explained in example 2.4. Distance of these 2 points gives you the distance of 2 planes. 4 steps. Any questions here? Okay. Let's say, so you want to write down the, I'm not so sure if it is in your online homework or the assignment. So you are asked to find the distance between a point and a line, a straight line. So again, you have to find a point on the straight line which has this property. I'm just going to draw it here. Okay, so the question is that we have a line, and by that I mean that you have the equation of this straight line, which means you have one given point that you're sure that this line passes through, and you have this vector, right? And then you are given another point, and you are asked to find the distance between this point and I'm just going to move this point here. So that was that random point that you had. So this is the equation of the line. R is equal to R0 plus TU. This is the vector U, and this is R0. So you have to find a point on this line that satisfies this, has this property, that if you draw a line from P to that point, I'm just going to call this one Q, this vector must be orthogonal to U, right? Distance between P and Q gives you the distance from that point to the line. This is the hint for, I think, the question for your homework. So if you want to find the distance between a point and between a straight line, you already have 2 pieces of information. One is this U, the vector, and then one is this R0. What you need is to find a Q. So first of all, Q belongs to the line. So use the equation of the line. So this Q has 3 coordinates, right? X and Y and Z. Plug them into the equation of the line. So this is the first equation that you need. Second one, PQ is this vector, PQ is orthogonal to U. You only need these 2 equations to find the point Q. So, and then the distance of P and Q gives you the distance between the point and the line. So this is what you need. Again, the question here is that to find the distance between a point and a straight line. You already have P. P is given. You need to find Q. Q belongs to the line. So it satisfies the equation of that straight line. This gives you the first equation. Second equation is that PQ, I'm just calling this point Q, is orthogonal to U. I mean, U is the vector for the straight line. With these 2 equations, you solve them. You find this point Q. The distance between P and Q is the distance from the point to the line. Any questions? Pardon? Okay, I don't have any example here because it's the question for your homework. I'll try to solve it next time. Okay, I'm gonna take a note here. Okay, so we discussed the distance between 2 planes, distance between a point and a line. So the last one is the distance between a point and a plane. Oh, we did it, right? Point and a line. I think we're done. So the distance between a point and a plane is obvious, right? You only need to find the reflection of that point and then the distance between the two. Clear? Okay, next time I'll solve examples instead of just talking and talking. So far, well, let's say in Calculus 1, you guys studied the functions of only single variables, right? So let's get started with functions of more than one variable. We do a couple of examples to reinforce the idea. Sketch the surface z is x squared. Well, first of all, we are working on three-dimensional space. So we always have x and y and z, right? There is not any general guideline to sketch these surfaces, but through these examples, hopefully you will get an idea how to approach these questions. So we have z is equal to x squared. The first thing that you should notice is that it is independent of y. So no matter y is, always we have the relationship between z and x is just given by z is x squared. So okay, so x and y and z. So let's say y is 0. Equation doesn't change, right? It's still z is x squared. So when y is 0, my intention is just here. This plane is x and z plane. So I'm focusing on this plane, x and z. Z is x squared and y is 0. This is the equation. This is the sketch for z is equal to x squared, right? When y is 0. Let's say y is 1. Equation still doesn't change, right? It's still I have this, maybe my pronunciation is not very correct, but I wrote it is parabola, right? Is that's the name for this curve? Okay. And then let's say y is 1. Still I have that parabola. And then I'm just plotting it. So no matter what y is, I always have this nice curve. So the next step is just to connect them. So what I have to help you, so I have this, I tried to plot this surface. So imagine here that parabola at y is equal to 0. And then this is y1. And then this is y2 or whatever you want, right? So this is the surface that I'm trying to sketch. It's not very clear here. My drawing is not very good. But that's the thing. I'm just trying to sketch it. So this is the thing that we are looking for. It's always independent of y. No matter what y is, always I have this parabola shape. Always. Clear? Okay, so the same style, but this time I have this surface, x squared by 1 plus y squared by 4 is 1, right? The first thing you notice is that it is independent of z. So start with z is 0, and then, so I have x and y and z. Let's imagine z as 0. Equation doesn't change, and the curve for z0 is just an again, my pronunciation might not be correct, but it's ellipse, right? This is the thing. This point is 1, this point is 2. Ellipse, right? I got the pronunciation right, hopefully. Okay, it's independent of z. So z0, I have this curve. z1, I have exact same thing. Just copy and paste. Z minus 2, minus 1, whatever you call, again I have this shape. Connect them together, I have a cylinder. So, sorry, it's not really a cylinder, but this is the shape that I'm looking for in this example. So, it's an ellipse here. Regardless of Z, I always see this shape. So it's like it is a cylinder. And to be correct, elliptic cylinder. So that's the shape that I'm trying to.
If Z is in the equation, why do you like move it up and down Z?
Because it's a three-dimensional space, right? We are asked to sketch it in a three-dimensional space. If it was only 2D, it suffices only to plot the one at the center. So basically, in two-dimensional space, we only draw this one. But for three-dimensional space, we have to. Actually, this is 2, this is 1. Okay, so this is like the first class of surfaces that you can sketch. Usually, the equation is independent of the third one. So you just pick whatever it is. Let's say the third one is z. Draw that curve for z0, and then repeat this drawing for z1, z minus 1, z2, z minus 2, and just connect these curves. And that's the surface. So the last one, 3.3, on this page, not for the lecture today, is find an equation for the, again, sorry if my pronunciation is wrong, oblate spheroid. Graph at the right, the x and y and z intercepts as plus minus 2, plus minus 1, and plus minus 2. So I have actually two pictures for you. How this shape is formed. Okay, if you have an ellipse and if you rotate it around the minor axis, so this is the minor one, the smaller one. If you rotate it around this, here is the oblate spheroid. So it starts with an ellipse, and then you just need to rotate it around the smaller, the minor axis, and that gives you the oblate spheroid. And the equation for this is given by this. You have to memorize it. I don't think if there is any proof or something for it, but you have to memorize it. So x squared divided by a squared plus y squared divided by b squared plus z squared divided by c squared is 1. And then a and b and c are given by those points of intercept. So this one was for x, this one was for y, and this one is for z, right? So a is given by 2, b is given by 1, and c is given by 2. So the final answer is x squared divided by 4 plus y squared plus z squared divided by 4 is 1. Here's a better view of that object, just like a watermelon. something. Any questions? So this equation that I just wrote, it's pretty general. If A and B and C are equal, then it is an equation of a sphere, right? X squared plus y squared plus z squared is a squared. This equation of a sphere, and that a is the radius of that sphere. Okay, next page. Okay, this part is a bit tricky. So a collection of level curves. First of all, what is a level curve? It is defined as, so I'm just going to write it down. You can write it down too. Level curve is a set of form LC of f. So f means that you need a function. For example, z is equal to f of x and y. So everything starts from a function. And then that c is the level that is of interest, and it's defined as sets of x and y's such that f of x and y is c. Okay, imagine a surface. Hopefully everybody can see it. I don't know what it's called, but a surface like this. Cone, yeah, perfect, cone. Yeah, so x and y and z. Everybody can see it, right? Yes? No? Good. So let's slice it from the top. So a plane just goes through this cone. The plane is parallel to x and y. This curve which is formed here is a circle. This circle is called level curve for, let's say, this is like 10. This point here is 10. So when C is 10, let's say I have the equation of this cone, but I know that cone is just consists of so many circles. So if I slice it from the top, I'm going to see a circle. So this is a circle. If I go slightly below, let's say Z is 8, I'm going to see, if I again slice it, if I cut it from here, still I'm going to see a circle, but the circle is smaller, right? So this is the level curve for C8. So the more I go down, this circle gets smaller and smaller, right? For here, I have this tiny little small circle, and then this is for, let's say C is 0.1. Just an example, right? So what I would do is just I would plot all of them together. So first that big circle, and I'm going to write here that this is for 10. When Z is 10, I'm going to see a circle. When it's 8, I'm going to see a smaller circle, but I'm going to write down that 8 here. And smaller and smaller. And this is for the 0.1, right? Let's say this is something like 5. So these are basically those level curves for different heights. So I have three-dimensional sketch of that surface, and these are just the level curves for different heights. 10, 8, 5. So to draw it here?
You zoom in because it's hard to read like the LCD.
So should I zoom in? Is that what you... Okay. Good. Okay. So this example is tricky, but because it's asked that start from the level curves and figure out the equation for that three-dimensional surface. So let's see. Okay, let's just start with the level curve when z is 12. When z is 12, the equation for the level curve is given by y is equal to minus 3 by 4 x plus 0. Do you agree? So I'm talking about this line here. This is the level curve for z is equal to 12. And then I just claimed that the equation of this is a line, and the equation of this line is given by y is equal to minus 3 divided by 4 times x plus 0. Hope you guys agree.
Did you just guess it was negative 3 over 4? Or did you say that? How did you get the negative 3 over 4?
Okay. Okay, do you guys agree that this line is parallel to the other one? So let's just start from that one. That would be easier. So let's say z is 0. What's the equation for that line? I know that it passes through these 2 points, right? So it is something like mx plus b. Actually, b here is 3, right? Because it passes through this point. And what is m? So, or a better way would be if I plug 4. So this point is 4 and 0, right? So let's figure out m. So 0 is equal to m times 4 plus 3, right? And then that gives me m minus 3 by 4, right?
Is C the y function? Like the two-dimensional?
Oh, the c here?
Yeah.
Well, let's, okay, sorry, c is better?
Okay.
Okay, so I started with C0 and I claimed that that level curve is a line, and I found the equation for the line, which turned out to be, so I'm just gonna write it here. Everybody agrees? Okay, so the key here is that we have to find the connection between, so you see here this slope actually didn't change. The only thing that changed was this 0 and this 3. So we have to find a relationship between these numbers here and then these c's here. So I suggest a linear relationship between these constant here and these levels. So what I suggest is that generally I'm looking for an equation like this. So this part, I'm just going to call it d of z. So this part, I'm claiming that it is just a linear function of z. It is move up. it is some alpha times z plus beta. And I know two things. Alpha times 12 plus beta is 0, and alpha times 0 plus beta is 3. How did I get these equations? So right side were these two guys, and this part, that linear relationship that I claimed that we have, and these numbers are just those C's, the levels. So the only thing that I need is to find alpha and beta. If you solve these equations, you will get alpha is minus 1 by 4 and beta is just 3. That means that original surface that I was looking for is actually a plane. The original surface that I was looking for was a plane. So these level curves, they were just level curves of a plane. So it's not an easy example. So limited information and so much to ask. We only had the level curves at 2 points or at 2 heights. One was Z12 or C12, and then the other one was at Z0 or C0. The first step, I found the equation for the level curves. Both turned out to be just straight lines. The slope of those lines didn't change. The only thing that changed was the constant part. I think it's called intercepts. So next step for me was to find the relationship between those intercepts and that C, the height, the level, right? I claimed that that relationship is linear. So this is that part that I claim it is linear. So I said that that part is just a linear function, alpha times z plus beta, and I had two pieces of information. Was that the first one was that when C or Z is 12, I need 0 here, and when it's 0, I need 3. So that way I figured out alpha and beta. And then finally I got the equation for the surface, which turned out to be a plane. Please, when you go home, redo this example, work on it, and then ask us, email us, or you have Peter's room number 53 something, 5th floor, math department, or email us, ask us to explain it again. You're going to see these examples like this in your homework, in your assignments, in your final exam.
So like if Z is like 2, it cut through all the
Pardon?
Can a single C value cut through 2 parts of the functions? Still maybe she.
No, it's just it's a plane, right? It's a plane. So when I cut it, I'm going to see a line, right? So these are the lines that I see here.
It's like in general. Like,
oh, in general? In general, it can be anything.
like a sine function expected.
Anything, yeah. But this example was easy, and it was intentionally easy, right? In your exams, assignments, don't expect something complicated. It's not going to happen. It's something either trivial that you can handle it, or it's not going to happen. Same level, right? Same level. Yeah. So example 3.4. Any question? Any question here? Please redo this example. Email us.
Sorry, where does 3 come from?
Okay, your friend asked this question, where did that 3 come from? Everybody's listening? Okay, so I started with finding the equation for level curve 0 when c is 0, right? It was given by this straight line which was passed through these 2 points. I used these 2 points to find the equation for the line, and that 3 came from that. So you have 2 points, you need to find the equation for the line that passes through these 2 points, right? And this 3 is actually this number here. But generally, if you don't know this one, just know you have 2 points, find the equation that connects these 2 points. Okay, any more question for me? Okay, example 3.5. So a collection of level curves of the function z is f of f, x, and y are drawn below. The inner curve is z1. So this is the inner curve here. And the outer curve, so this is for z1, and the outer one, which is this one, is z is 16. Well, this z here is the c that we discussed for the level curve, right? This is just the c. Doesn't matter which one you choose, either c or z. Okay, so so let's start with z is equal to 1. So the equation when z or c is 1, the equation of this is another ellipse. The equation is given by x. So this is 1/2, and this is 1, right? So x divided by 1/2 squared plus y divided by 1 squared is 1, right? And when z or c is 16, I have, so this is 2 and this is 4. So I have x divided by 2 squared plus y divided by 4 squared is 1, right? So what I did, I just wrote down the equations for those inner and outer curves, level curves. The key is that you should look for a trend. So let's simplify the first one. It is actually 4 times x squared plus y squared is 1. And then the second one is x squared divided by 4 plus y squared divided by 16 is 1, right? So let's multiply the second one by 16. What I will have is 4 times x squared plus y squared is 16. So this is basically this one, right? I just multiplied both sides by 16. As I said, you need to look for a trend. So when z was 1, I had 4x squared plus y squared is 1. And when z is 16, I had 4x squared plus y squared. See the same terms as the previous one. However, on the right side, instead of 1, I have 16. Do you see the trend? So when z was 1, on the right side I had 1. When z is 16, on the right side I have 16. And the equation then is z is 4x squared plus y squared. It's just you only need to look for a trend. Yeah.
Two like instances enough to prove a trend.
No, you're right. It's not. It's just the easiest thing that comes to mind. It's not a proof. As you're right, it's not a proof. It can be anything. There are actually infinite solutions for this answer, for this question. You're right. It's just the simplest things that comes to mind. It was a valid point. By only 2 points, we cannot really say this is a trend. But this is just an educated guess. This is the best thing, or the easiest things that just comes to mind. So in your homework, I've checked the online homework, online practice test. So you have something like a multi-option test that there is an equation and there are a couple of sketches and you are asked which belongs to which. So you can use this technique here to assign those equations to those surfaces. Any question for me? Okay, so next time I'll bring some examples about the distance problem, point to the plane, point to the line,